Okay, let me give you a brief bio of Andy Peytchev. His research interests include study designs that minimize total survey error. He is particularly interested in the study, reduction, and adjustment of non-response and measurement error. Dr. Peytchev's recent work includes the evaluation of split questionnaire design. Funny, we're looking into that for censuses, so we'll talk about that later. Multi-frame and multi-phase study design, development of adaptive and responsive survey designs, augmentation of survey samples with external data, and evaluation of their properties and imputation for unit non-response and measurement error. Prior to joining RTI, Dr. Peytchev was a research assistant professor in the survey methodology program of the Institute of Social Research at the University of Michigan. He has given talks and participated in expert panels to inform the design of major national surveys and has served as an associate editor of journals and as standards committee chair for the American Association for Public Opinion Research. His current interests include the use of administrative data to improve survey inference. So, without further ado, I give you Dr. Peytchev.
All right, so can you hear me well? So one thing that would be good is if you have any questions or ideas or whatever, you can interrupt. This could work great as a discussion, as long as you speak up. I wish I had actually coordinated with Barry because we probably could have split up so that one of us would have provided a better discussion and presentation of what an adaptive survey design is and what a responsive survey design is. But I'll try and do that. Better late than never. So here's a quick outline. So I'll do my best in a very short time. I know Barry, Shelton, and James Wagner and I have all-day courses on just laying out what an adaptive survey design is. We'll have to do that in about 5 minutes. Non-response and cost, and a presentation on that. And then what I'd like to focus on in this presentation is a lot on the motivation and being very specific about setting the objectives of what you want to achieve. Having said that, it also means that there's more than one objective that we have in our surveys. How you rank order these objectives can lead you to very different designs. I'll run some empirical examples in two ways. First, I'll present differences across 3 surveys that seemingly go after the same objective, but lead them down very different designs. And then another one that we just finished the analysis just a couple of weeks ago, that if we have time, I'll present on that. And then a summary, and then hopefully we'd have time for a discussion. So, as I said, I'm not going to go into the detail. If you wanted to go into what exactly is propensity stratification or different ways of breaking out the sample so that you can go after them, or how you can optimize an adaptive survey design, we spend a lot of detail on those topics. So what are responsive designs and adaptive survey designs? First of all, they're 2 different things. It doesn't mean that surveys actually don't generally do both at the same time. Both are responses to current challenges that we have in surveys. And so we saw some of the earlier presentations today delve into those. And they evolve in different contexts. So you'll see that some surveys are better set up for responsive design. Some surveys are better set up for adaptive survey designs. Both have some roots going back. For example, clinical trials. Those are studies where an adaptive design in a clinical trial is something that you learn over the course of the clinical trial. You may stop the trial sooner. You may change the dosage. These are all being adaptive in a different kind of setting. So all this is kind of the basis for where these designs are coming out from. So in a responsive survey design, and that was proposed by Gross and Heringer over 10 years ago now, Uncertainty prevails. I can say that more directly. So it's typical for survey designs. Maybe it's a single survey implementation, or you're starting a survey, or you don't have much auxiliary information. You don't know what protocol would work best. These are the kind of settings that really led to the development of responsive survey design. But the uncertainty is reduced over time, and then the designs are typically in phases. So you may experiment in the early phases of the design, and then learn and apply that to subsequent phases. How you decide to postulate what a phase is, sometimes that could be even replications of the same survey design, and you can learn over time within the same survey. More typically, it's within the same survey data collection, you design multiple phases in which you may experiment and change your protocols. So there's some learning that happens. Often these phases change the protocols, and most typically they also escalate costs. So they become increasingly more expensive for the sample that you haven't been able to interview early on in the earlier phases. Phases are complementary, ideally. So one of the, I think it was in Barry's presentation, where you have phase 1 and maybe the response rate is highest among one subgroup. You want phase 2 to maximize the response rate in the other subgroup, where the response rate was lower in the first phase. That's an example of complementary phases. Your second phase is actually working better for the people that you're missing out in the previous phase. So there are 4 steps in their responsive design. One is to pre-identify a set of design features that you can change and that would affect cost and error. Identify a set of indicators, and that's instrumental. You don't know how well you're doing unless you put the thought before you even implemented the study on how to measure the outcome. How well are you doing in achieving your objectives and tracking these survey errors that you're trying to manipulate? Alter the features during the survey, right? So the things that you've identified in step 1, they must be alterable. They should be under your control. Here you do control them. And then the last step, which probably has received the least attention, is combining the data. So you do implement multiple protocols. You may do various forms of subsampling or targeting of cases. In the end, you need to combine the data and into a single estimate. What wasn't really a step in their process, but still is clearly defined in their paper, is specifying the objectives, being extremely clear about what the objectives of that design are. So in an adaptive survey design, the setting is a bit different. Typically, you have some information on your sample. Sometimes that can be a lot of information in your sample. In Barry's presentation in the Netherlands, they start the surveys, and the ones that he gave examples, from a register, a national register that has all the information that you saw. They define these groups based on the sampling frame. And some of these variables you would treat as substantive variables. Some of these variables we collect in the United States as key estimates in a survey. For them, they're on the register. That means that they have information on the sample that then they can calculate an R-index and go after cases based on that R-index. It's possible to identify subgroups that become either more valuable, or you can identify them as being different, maybe different in how they respond to different protocols. Maybe one subgroup responds to a different mode better than another subgroup. That would be information that you could use here to define these separate strata. And by strata, we don't mean sampling strata. These are design strata as part of the adaptive survey design. Prior experimentation with the design alternatives helps. So how do you know what treatment to be even manipulating these cases? So you identify some subset of cases, but still having an idea of what protocols work for them can be a good starting point on what you can do. Use targeted designs for each subgroup, and then optimize for cost and quality. So you can even go back to the drawing board, and after you've implemented your design, you can think exactly how do you want to modify and optimize. And that optimization, I think Barry had a slide on that. It can be a mathematical, it could be a simulation optimization, and it could be trial and error when you completely don't know what works best. There are different approaches to how you optimize the design. So I think I went through many of these. So define your objectives. That would be the very first step that you would do in an adaptive survey design. Do you want to control your costs? Do you want to decrease your variance? How about bias? Do you want to produce your estimates faster? And all these objectives, as you see, one, they're not mutually exclusive. You can have 2, 3, or all of these objectives. Another thing that becomes important then, which ones do you want to optimize the design for, and which do you treat as constraints, possibly? Can you rank order which ones are the most important and go that way? Then identify strata. Again, these are design strata. How can you subgroup your population in a way that meets these study objectives that you want to target subgroups differently? Match the designs to the strata. That is really, really important. Think about having a manipulation, say, like an incentive, a larger monetary incentive to go after a subgroup. But if that subgroup tends to be a subgroup you cannot contact, well, that manipulation is not matched to the subgroup, right? That manipulation is matched to a subgroup that maybe has a high refusal rate that you can contact, because an incentive is useless if you don't get to the cases. That's a really basic example of matching the intervention to the strata. Identify indicators for each objective. How can you measure? So the R-index is one way that you can say, based on the auxiliary information, am I balancing the sample better than I was before without the intervention? And then optimize the design. That's the part where I said, yes, there are multiple ways of optimizing a design, but before you go into data collection, but also after you've done everything. Here's a very simplistic attempt of trying to bring it all together, because many of the surveys that we do are responsive designs. They're adaptive survey designs within phases of a responsive survey design. So the responsive design provides us a framework to use multiple phases with varied protocols. Each phase is defined by the introduction of some different protocol, whether it's a different mode, it's a different incentive. You're telling interviewers really to focus on a subset of cases, and if they have to, they will just sit out in front of somebody's house until they manage to interview. The adaptive survey design is different, because here you're tailoring to the sample. You're trying to identify subgroups or individual cases that you want to give a different treatment. And that can be for a couple of major reasons. One, you think some protocols may be more effective for them, right? So identify some cases for which maybe a switch in mode makes sense, but for other cases that wouldn't. Some of Barry's other work, for example, tried to optimize designs not just for non-response, but for measurement error. So you could think, for measurement error perspective, you may not want to apply a different mode for some subgroups, because you'd increase the overall error in the estimate, and you need to optimize for multiple error sources. And then you can also, probably the more typical example would be prioritizing sample cases or sample elements because they bring different value to you. It could be, if you're trying to optimize for variance, it could be cases with larger weights. Even more typical, are there cases that you think that if you don't bring into the interviewed sample would lead to greater non-response bias in your final estimates? So the cases that you're missing. And so those may not be particularly responsive to your protocols, but those become the cases that are of particular value to you. So this will be a very quick motivation for non-response and cost. Key factors driving the development of both responsive design and adaptive survey designs is increasing costs and rising non-response. I don't think there's much doubt about that. Now, having said that, yes, you can target other sources of error and other objectives with these designs, but this has been largely the motivation for why these designs have risen. And so I make a note of a couple of just simple examples of how these designs have been used for other objectives. Even in the Gross and Heringer article, they give an example of, do you select one adult in a household, or do you select two adults in a household when you're selecting your subsampling within a household? Well, there are different implications, both for bias, variance, response rates. And you can imagine that you don't know which design works best until you test it and you have a means to evaluate how many people within a household do you interview, and then go forward with that protocol. So that's just an example of something where sampling error may be the key objective here, not non-response. So I'm not going to spend much on this, just to show you a very high level of major surveys in the United States and what we're facing. And in fact, these lines have continued to decline since then. One thing that I want you to take note of is this brownish line. That's the National Survey of Drug Use and Health. And that's the one that you can see is not very, very stable. We'll come back to that in another slide. So again, focusing on the National Survey of Drug Use and Health, which was the brown line, this is a subset of the years. What this is trying to illustrate is why we're concerned about these declining response rates. So here you see in the purple lines, that's the past year prescription drug use. That's a key estimate for this survey. It's about drug abuse. The red lines are the response rates in the survey. So this is not a causal analysis. Nothing is being manipulated in order to understand it. I think what the striking thing is that the patterns for the estimates and for the response rates seem quite similar. And so if you run a regression, you actually do a really good job at predicting the estimate using the response rate in the survey. So that's our concern, right? The result of these declining response rates, if these are correlated with our estimates, we're biasing our estimates, point estimates in any given year, but in the survey that's producing estimates of trends, it's also biasing those estimates as well. So finally, this is the last slide I'll spend on this survey. But remember those peaks that it wasn't really smooth? This is a blown up version, just inverted because this is the non-response rate instead of the response rate. And so you see that between these lines, the vertical lines that I've put in here, this is fairly stable, right? There are no major spikes, but you see spikes here, here, and here. So in 95, this survey was shortened and simplified among other changes. So response rates increased. Another way of saying it is the non-response went down a bit. Some changes happened in 2002. A major change was the survey up to this point didn't have any incentives. At this point, a $30 monetary promised incentive was introduced. So here, non-response dropped again. And then here, we see a spike in non-response, right, an increase. And so the change here was one by design. The survey went from producing national estimates to producing state-level estimates. Any guess at why that would result in higher non-response? Any wild guess? The sample size, but think about everything that we do to the design has implications to our data collection protocols. In this case, if you're ramping up to produce state-level estimates, because you're increasing your sample size, you also have to hire many new interviewers that would be new to the project. You haven't even experienced the attrition that you normally would from the interviewers that don't perform that well. So then you have another spike. So from all this, the main story that I want to tell is that we know that our outcomes, survey outcomes, like response rates, are very sensitive to what we do in our data collection procedures. So flipping that on its head is really what we try to do with both responsive and adaptive survey designs. We try to manipulate those features in a design so that we can achieve our desired objectives. No need to motivate much about rising costs, but some of the very large examples. The largest data collection by far and the most expensive in the US is the decennial census. And so even for the adjusted cost, if you compare it from 1970 to 2010, and it's fairly smooth if you look at it by every decennial census, that's a rise of almost 500% in the cost to enumerate a household. So it's not a function of the size of the population either. We see other evidence for this, that surveys that we've done since the 1970s on an ongoing basis, at releasing samples every month within the same design. These surveys have had to increase the level of effort only to slow down the rate of rising non-response. So this is really key to adaptive survey designs. We know that the population is heterogeneous. So if we put adaptive survey design to the side for a second, the way you would normally design a survey would be, what would work best? Let's see what modes, what's our sampling design, what kind of an incentive do we offer, and we treat the sample all the same, right? We just try to optimize it to what works best for most of the sample. If you put a question mark on that, then you say, but people are different, and they respond to for different reasons. And so the sample is heterogeneous, and if we can understand that heterogeneity, then we can leverage it in these designs. A key part to this was some key work on this was demonstrating in experiments on non-response that the monetary incentives work best for the people that had lower likelihood of participating and that were less involved in the topic. So that would link both non-response bias and response rates with a treatment that you know that you can use for that subgroup very effectively. So then that's kind of the idea that I already brought up. How can we leverage it? We can identify subgroups, identify strategies to use on those subgroups. And so an example, we use a web survey for subgroups that are likely to respond on the web. This is the last of these theoretical slides, but it's an important one. I can spend probably an hour describing this theory. But the very bottom line is, people have different leverages for different things. So for example, the topic of the survey or the incentive amount or who's the sponsor of the survey can have a different leverage for every person. Sometimes it's positive, sometimes it's negative. So the topic of the survey may appeal to somebody, but actually get somebody else to refuse. That means that they have different leverages on their decision to participate. And we, as survey designers, actually make these features more or less salient. So interviewers are the best example. They make these features at the doorstep more or less salient. And what we strive to in our design is making sure that we kind of match up, that we use those leverages that people can have. These are not observed. We don't know what a particular person would respond to, but we try to use the auxiliary information to try to group them based on these leverages, ideally. Okay, so optimization for multiple objectives. It would all be really simple if we just wanted to optimize the design for only bias or only variance and really not care about the other objectives. In Barry's example, you could optimize for one, maybe for two things, but then the rest you just set as constraints. Another way to look at this is some of these are more of soft constraints, and so you still, from a design perspective, need to consider multiple objectives and figure out which one is more important. So consider a design where the main objectives are to reduce non-response and reduce the risk of non-response bias. That's a very common one. In a responsive design, you'd set that up into multiple phases. So you have only two phases, a main data collection, phase one, and then some more expensive protocol that should be more effective at getting the people that you're not getting in that main protocol that you label phase two. And you may not be able to afford that protocol for everybody in your sample, only for a subset. Oh, let me introduce three surveys. So the first one is the high school longitudinal survey. The second one, so that's a survey of students. The The second one is the National Survey of Family Growth. That's a household survey. And then the National Intimate Partner and Sexual Violence Survey is also a national survey, but done by phone. And so what I've tried is almost reverse engineer, based on their design, how they rank ordered these multiple objectives. And we'll go through the steps on what these design components were and how they ended up. So to start with, all these surveys have the objective of reducing non-response and reducing the risk of non-response bias. But they have these multiple objectives in there. So one is bias, another is variance, and even number of interviews, right? If you have a set objective of how many interviews you need to do. There's response rates, and there's cost. And these are the four objectives, but then you see that the order is different. So in NSFG, response rates and number of interviews could be placed higher up on the list. And cost is also among the top two. On NSFS, the Intimate Partner and Sexual Violence Survey, bias is at the very top, and so are response rates. You notice that in HSLS, the first survey, the second objective is variance. That wasn't the goal in any of the other two surveys, not at least among the first two top goals. So, why would these designs differ? And this is where it does take expertise, and thinking of an adaptive or responsive survey design is not something that you read in an article and you say, I'll just do exactly this. But you need to go back and say, what are my objectives, and let's design whatever the intervention would be to be tailored to this. If maximizing the response rates were the main objective, then you could subsample the non-respondents. So that's called two-phase sampling for non-response, or double sampling for non-response. The people that you select, the sample elements that you select in that second subsampling into phase 2, receive an additional selection weight. They've been subsampled. So they account for more than one respondent compared to phase 1, right? So you get more bang for the buck in a way, right? You disproportionately increase the response rate by using the subsampling. But the cost that drives is that you increase the variance of your survey estimates, right? You increase the variability of the weights. Oversampling cases more likely to respond. Well, that sounds good, but maybe that wouldn't be the optimal approach if you're trying to minimize the risk of non-response bias, if you're still going after cases that are relatively likely to participate and not the ones that you're missing. You could try to reduce the risk of non-response bias as a main objective. So subsample among the non-respondents again allows gaining participation from those that you're missing. But more importantly is that second point. You can target cases. You can identify cases that you're missing based on auxiliary information and try to incorporate those so that you balance your sample based on really on your main objectives, on your main key survey estimates. That, compared to other designs, may actually achieve a lower response rate compared to going after high propensity cases, right? You can reduce variance. Well, in this design, you probably wouldn't be double sampling non-respondents, not applying a second selection probability, right? You can identify cases after which you would like to go because you're missing out, and maybe you'd be reducing your bias, but you wouldn't want to apply yet another selection probability. And finally is to reduce cost. So you could subsample at a very low rate, and some surveys do. So for example, in the NSFG, among these 3 surveys, it subsamples about a third of the non-respondents from the previous phase. Well, that means that the weights for these cases that get interviewed in the last phase are 3 times larger than the weights for the cases in the previous phase. So that's just a recap of what we just went through. So that's the 3 surveys that we rank ordered and how they had the same objectives but in a different order. Essentially, this is the kind of designs that they have in going after non-respondents. So in HSLS, there's no double sampling of non-respondents. They're just selected based on a model, and the cases that are not selected still continue with the previous protocol. They're still in data collection. And then the selection of these cases is purely based on a propensity model trying to identify bias. And that would be the next example. We'll delve into an application of what if we design that propensity to be not just a response propensity, but more like a bias propensity, and be more thoughtful about how we target those cases. In the NSFG, it's a double sample of non-respondents, and it's also targeting segments that have more non-respondents and higher response propensities. I mean, given that these already have exhibited higher, lower response propensities because they didn't participate in phase 1, still among the remaining is the higher response propensities. And then on NSFS, it's a double sample of non-respondents, but it's a stratified random sample. There's no difference in the rate of subsampling among different groups. And it's just trying to, it's no targeting of cases, it's just trying to adjust for the subsampling fraction. And that doesn't blow up the variances any further compared to NSFG. So a summary on objectives: clear goals need to be set for each study and rank ordered so that the design matches exactly those objectives, and that you're not messing up some other part of the survey that you really care about. And all these objectives have trade-offs. So here's an empirical example, and after that, we'll have some time for discussion. So this is HSLS, the high school longitudinal survey of 2009. It's 2009 because the initial sample was drawn back then, but this survey was actually a 2013 update. It's a national probability-based sample of approximately 20,000 ninth graders. So by 2013, most of them were just out of high school. And we had 7 phases of data collection. Initially, there were 6, and then unfortunately, just like what we just saw, the government shut down in the US, and that created a 7th phase with a different protocol. For this analysis, we'll treat it as a 2-phase design with a non-response follow-up and group them together. And I'll go back to that point again, because I think that's one of the limitations that we have in finding evidence for whether responsive and adaptive survey designs are effective, is the kind of studies that we try to evaluate it in. So in this redefined data collection design, in which we said we have just phase 1, phase 2, and then additional effort to go after the non-respondents, what we're interested in is what do we do in phase 2 to reduce the bias, what if we stop after phase 2 and we want to have the least bias in our estimates. That gives us a nice design also for evaluation of these outcomes. So in phase 1, no incentive was used. In phase 2, the treatment was a $5 prepaid incentive. So that was just mailed to the sample member, regardless of whether they were willing to participate. And then additional phases of data collection, and then those additional models were applied, additional adaptive survey designs were applied, incentives were increased for some to $15, for some to $25. And then we also have full sample information for everybody on the sample. Now, those are not the most interesting variables, but then it just gives us a full sample estimate for non-response bias. So we specify the objectives and the general approach. So it's sequential introduction of protocols, right? The $5 prepaid incentive is the introduction of something different in a protocol. We select cases after phase 1 based on some criteria on minimizing non-response bias. The challenges that we have here and that we've identified is how do we best identify the cases that are contributing to non-response bias during data collection? And the second one is how do we balance a trade-off between evaluation of the intervention versus getting maximum benefit from the intervention? So that last one, I can tell you, we lost that battle, and so there was no control group. And I'll tell you that at least the methods that we used in order to create that control group afterwards. But it's still a balance that you'd have. There's a treatment that you think is far more likely to succeed, and you'd like to apply it to the full sample rather than set aside half or a quarter of the sample to be a control group. So in this study, phase 1 was a web survey, later introducing telephone. And then in phase 2, the same data collection design, but introducing the $5 prepaid incentive. Now, this is the key part of this study. This is what we believe is the innovation part. You can think of a response propensity as something where you're trying to maximize the prediction of whether a case will become an interview or it wouldn't become an interview. And in that model, you can think of it as a kitchen sink approach. Anything that's correlated with non-response, you'd throw in there. The downside to that is the biggest predictors of non-response are variables that are paradata that really are almost endogenous to the non-response process. So examples of that would be, has the respondent refused at an earlier time? Now they're still part of the sample and we still go after them. And that variable thrown into the model would overwhelm everything else because that would skew the distribution. It gives almost perfect prediction of whether the person would respond or not. In this case, we deliberately threw out paradata like that, and we kept only variables that we cared about and that would be related to the Y variables, to the survey variables of interest. So that included demographic characteristics, but it also included variables like how well did that kid do in school in an earlier year? Well, school performance in a survey of students is a key estimate. And so we want that to be driving our bias propensity on how imbalanced our sample is. So I'll just give some example on what variables, because I'm not going to show you any of these variables. I'll just give you a summary statistic in the end. And then lastly but not least, we didn't have a control group. So that was another problem we needed to overcome. And maybe this is why it took us 5 years until we figured out how, and we just finished analyzing that winter. So the analytic approach, so we had a bias propensity model, and based on those bias propensities, we targeted cases in data collection and we offered them the $5 incentive. Once the data were collected, then we fit this model again, but then we added the paradata in there as well, and we threw in an indicator for whether the case was in the treatment group. What we're trying to do now is estimate the treatment effect and estimate what the propensity of the case was to be treated so that we can create a control group. We can say which of the interviewed cases in the treatment group would not have responded had they not received that $5 incentive. Based on that, then we can subsample and create the control group. So that's just the gist of it. I'm not going to go through the entire slide. So we have this graph both as a curvy linear, but I think it just makes more sense, at least for presentation, for simplicity, as a linear. So you see on the horizontal axis is the bias propensity prior to the intervention. And then on the vertical axis is the response outcome. And so this is a regression discontinuity approach, an approach that's typical when you don't have a control group and you try to estimate what the treatment effect is because it was at a cut point based on the horizontal axis. And so we see that, yes, the intervention worked, and we estimate what that treatment effect is. And in essence, then we can control for that delta and create the control group. And then finally, our results. So the results are split into two sets. The first set is for variables that are available on the frame, because this way we can also evaluate how well our non-response follow-up procedures worked as well. And then the next results I'll present would be the ones that are only for the key variables that were not on the frame. So what you see here, and that would be the key. So this is phase 1. This is the main data collection, and you see most of the interviews are collected here. And this is the web and phone without any incentive. This is phase 2, but simulated as if we didn't introduce the $5 incentive. Right, so this is the non-adaptive survey design. And then this is the responsive and adaptive design part where we did target the cases and we offered them a $5 incentive, right? And then we calculated, we also have relative average bias, but this is just the absolute average bias using the gold standard. Now the gold standard we mean by the frame, the sampling frame. And then we also calculated using the additional phases of data collection. So that still is subjected to some non-response, right? This is after we gave them $15 and $25 throughout. And so the average bias here in phase 1 was 2.1 based on the gold standard, and then based on what we found at the end after the extended effort was 2.8. That was exactly the same if we didn't introduce this design, right? So phase 2 didn't really change that bias. Going to the adaptive survey design, we changed that bias. It went down a bit, right? So this is averaged across multiple estimates. And then the last one, it also has an estimate of what's the average bias in the extended effort data, right? After we gave them all the possible ways of responding. And then it converges to 0, which gives us more confidence that we can use the extended efforts that we typically use. Which really underscores why in previous evaluations of adaptive and responsive designs in this type of survey, where they're well-funded and they have multiple interventions with multiple phases, we generally haven't found big evidence for why adaptive and responsive designs work. It's because we throw everything at them over an extended period of time, and in the end, you can't do that much better if you're throwing resources. These adaptive and responsive survey designs are most valuable when you are under resource constraints, right? That was the very motivation for why we're delving into these. And so lastly, these are the most important variables on the survey. This is the subset of variables that are not on the frame and really are considered key estimates. So the phase 1 estimate has an average bias of 2.2. If we had continued with the same protocol in phase 2, we would have had an average bias of 2.1, but it would be 1.8 with the adaptive survey design. And again, this is an NA here. So in summary, contrary to some of our prior experiments, this more direct approach, it's more direct because we tweaked it. It's not exactly a response propensity. We were deliberate of what variables we would use in those logistic regressions estimating non-response. And that's why we called it a bias propensity. One factor that we deliberately isolated is the overall level of effort. And that's what I just described. It's kind of unfortunate that many of the surveys that can afford responsive and adaptive designs, at least in these more earlier years of evaluation, are also the ones that tend to have better funding. And so, in a sense, they're actually ill-equipped, ill-prepared to detect these non-response biases and the treatment effects. We need these adaptive survey designs to be implemented more frequently in these lower-cost surveys where they can potentially have a bigger impact on the outcomes. And with that, I end. Nobody interrupted with any questions, so now's your time.
There is one.
Thank you. At the beginning, you mentioned that the adaptive designs can be applied to this area. It is usually very strict and specific, and it is possible, according to FDA regulations and everything, sometimes to have an interim analysis, and that affects your significance levels for hypothesis testing. So I would like you to comment how, I guess, adaptive designs, if you applied it to clinical trials, you will have to make such type of corrections to the alpha, or is there specifications about this in particular? And another thing is, apart from that first question, I'm very curious because in the late years, in the world, we've had several surveys that have failed. Tell the Brexit, tell US elections, a survey in Colombia about peace. Is there any research to see how maybe an adaptive, how was the non-response and maybe how an adaptive design for a future surveys on these topics may be applied and get better estimates? Thank you.
All right, so the first question about, so clinical trials are a good example because they go to extensive length of how they apply adaptive survey design. If you put it in Google and search it, and that actually probably will show up under clinical trials. They have books exactly on how do you design it and tailor the intervention and monitor it and change it over the course. And they do have complex statistical methods on how would they combine the data. Our survey designs are not that complex. And so when I said that in the responsive design, the last step was how do you combine the data into a single estimate? And when I made the comment of this probably area has received the least attention, I strongly believe in that. So part of my response is to say, for all the students here, that's a nice area to go after. There's probably a lot to be done on that side. As these designs become more and more complex, there'd be an increasing need to try to account for these design changes. Now, given any given specific design change, then we can talk through on how it's being implemented. But I think in general, very high level, that's probably an area that deserves more attention. So that's a very insightful comment. The other part about why are surveys failing, and particularly the polls, now that opens up a lot more questions than answers. And so a lot of work has been done exactly on both Brexit and the US elections, and the answer is not so simple. So the polls would be the simplest one to pick on because it's not just non-response, it's a sample size issue as well. In the US, actually, the predictions worked well in some states, they just failed in others, and the sample sizes are not even sufficient, let alone the methods are not stringent enough for these polls. But even more than that, they're not a straightforward survey. They do sampling, but a big component of that is likelihood voter models. You need to estimate whether the person would vote at all. And that's probably the biggest failure in both of these. Who would come out and vote? It was certainly a big problem with Trump, especially if you look by education. Any survey that didn't account for education didn't also account that, and the likelihood voter models are based on past data. Nobody anticipated that people with lower education would turn out in the same rates as they did for Trump. So that's kind of a different issue. But I do think that pretty much any survey can benefit from a design like this, as long as it can stipulate exactly what are the biggest threats, and then go back to the design board and redesign the survey in a way that helps.
Hey, thank you for your presentation. We are currently working, I'm at the the Census Bureau, but from Mexico. We're currently augmenting and standardizing the paradata that we ask of the data collection process. One of the objectives of augmenting this set of paradata is to actually study non-response in a more systematic and try to start using this kind of methods. What would be the things that you would recommend that we include in those requirements so that in the collection process, the paradata is being generated so that we can start this kind of analysis?
That's a challenging one. But I think at least, first of all, you're on the right track. I think the surveys that have made the biggest benefit out of paradata are the ones that didn't say, what do we have available, and just use it, but have actually sat down before the survey and thought, what paradata do we need to collect? And the term has expanded over the years. It's no longer, did a person refuse, or keystroke data. Now they're expanded to even mean interviewer observations. And so there are several examples, for example, with interviewer observations, where a deliberate effort has been made to collect observations that are relevant to the survey, particular survey. So the US Census Bureau has this CHI instrument, CHI. It's an acronym. They tried to have kind of a standardized instrument to collect paradata from multiple surveys that they conduct. But then surveys like the National Health Interview Survey have gone an additional step in saying, can we modify that and actually collect more variables that are particularly useful for us? The National Survey of Family Growth is probably the best example because they study fertility. They actually have an interviewer observation of whether the person, the sample member, is sexually active. And that the interviewer is actually recording without asking the question. And so that is used then to drive their responsive design because they can identify subgroups that are underrepresented based on estimates of the key survey variable. Now, this is fraught with measurement error, and you can imagine, even the interviewer variance in these interviewer observations is really high. But it still found helpful. And there was an earlier question on one of the previous talks about, well, could you do more harm by using variables like this? I think it's worth considering, but I honestly don't think that that's the biggest concern, right? If you're weighting your survey data and you're producing your survey weights, I think using variables that have error in them can be a big risk. You can actually introduce bias in your estimates. Using data, paradata that may have error, and particularly uncorrelated measurement error, then the risk is much lower. It just typically would render your intervention less effective, but it wouldn't necessarily bias your estimates. So going back to your original question, I don't think there is a particular list of variables that anybody can tell you, you have to collect this. I think going back in the responsive design, if you look at what the second step was, it's identify those indicators. And think about for your particular surveys, what are those paradata that you need to collect? I mean, if you're going to model something that you're constrained by cost, then certainly having good measures of cost and drivers of cost you'd need. So you'd need to track interviewer travel times. I mean, if you're compensating them for travel, it's examples like this. And I think some of these make it out into the non-peer-reviewed literature. Like an example would be the Joint Statistical Meetings proceedings in the US. That's a nice place to find what people are doing on the studies.
Any other questions? I have time for mine. So, well, as Dr. De Alba mentioned at the beginning, in the opening of this session, and as we talked about these matters just earlier in the morning, comparability comes to a big issue in the production of successive of information, statistical information from successive interviews or collection exercises for the same survey, say an income survey or a labor force survey. The introduction of changes in protocols, in any of these aspects of the survey may hamper the possibility of carrying out sensible comparison between success. Is there anything you can suggest that we can try and implement to avoid precisely that and still consider adaptive and responsive?
That is a really challenging question, a very, very broad one too. So Poe and I work for an RTI, and so many of the surveys we do end up producing official statistics. And so a key concern is you don't want to be affecting your estimates of trends or changes over time. So it does become a factor on what are you doing during data collection. I think the flip side to that would be the argument of saying, well, are you content with staying with exactly the same design, knowing that response rates are declining, And by doing nothing, you're actually doing a change, because society is imposing a change. And so the example with non-response is probably a simpler one here, because you can say, we're under circumstances of change, and we're trying to address that change and reverse it. And so many of the things that we try to do are, we try to optimize the design to use unbiased estimates and estimates of trends. But again, I think the HSLS example is an example of an implementation of an adaptive survey design that should have included a control group. And so we do have responsive survey designs where, and especially the adaptive part on selection of cases for differential treatment, where even though it's part of the protocol, and we do it in every implementation of the survey, and the survey is implemented every 3 months, we still always maintain a control group. Because you still need to build the estimates on how to inform the next implementation, and you also need to know how well you're doing. And that control group then you can use for multiple things, including are the changes you're implementing affecting your survey estimates. So I think a key part to this is, when you can, always try to include a control group. Now, the conversation we had earlier is kind of different. Now, if you have an intervention that's at an interviewer level and you don't really have that kind of control, it's different. But again, for the vast majority of cases, you have the luxury of having a control group.